On a crisp July morning in 2025, the Atlas Survey telescope in Chile pierced the pre-dawn sky, capturing a fleeting streak of light that would soon ignite a firestorm of wonder and debate. Moving at a blistering 130,000 miles per hour, a mysterious object designated 3I/Atlas blazed into our solar system, marking itself as only the third confirmed interstellar visitor in human history. But this was no ordinary comet. Its behavior defied the laws of physics as we know them, leaving astronomers, scientists, and dreamers alike grappling with a question that hums with cosmic possibility. Could this be more than just a rock from the stars? As NASA's data poured in, revealing a sunward plume and a chemical makeup unlike anything seen before, the world found itself on the edge of a celestial mystery. Buckle up. This is a story of science, speculation, and the unknown, and it's one you won't want to miss. Picture the scene, July 1st, 2025, just hours after the Atlas survey logs a new object slicing through the cosmos. NASA's press office buzzes with urgency, releasing details that send shockwaves through the astronomical community. This isn't just another comet or asteroid, it's an interstellar traveler hurtling toward us from beyond our solar system at a speed that makes even seasoned astronomers double-check their math. With an eccentricity of 6.141, 3I/Atlas follows a near straight path, a trajectory so precise it feels almost deliberate. Most comets curve gently through the solar system, but this one cuts through like a cosmic arrow, threading the needle of our planetary neighborhood. What sets 3I/Atlas apart, though, isn't just its speed or path. It's the plume. Unlike every comet ever observed, which trails dust and gas away from the sun, 3I/Atlas sprays a bright, persistent plume toward it. Imagine driving through a rainstorm, the droplets streaking backward off your windshield. For comets, solar radiation acts like that wind, pushing material away from the sun to form a glowing tail. But 3I/Atlas, it's as if the rain is flying into the windshield, defying the relentless push of sunlight. NASA's own images, captured by the Hubble Space Telescope and confirmed by observatories like Gemini South and Lowell Discovery, show this anomaly in stark clarity, a blobby, sunward arc that refuses to behave like any comet tail in the record books. This isn't a subtle quirk buried in the data, it's the headline of NASA's press conference. Veteran comet researcher Bryce Bolin, speaking with a mix of awe and frustration, sums it up. The plume is blobby, and it's preferentially going into the direction of the sun. The Atlas team, alongside NASA's planetary defense experts, scrambles to model this bizarre feature. Comparing it to every known comet, nothing matches. The dust is too heavy to be swept back by solar wind, yet it's ejected with enough force to hold its shape against the sun's relentless pressure. As the data piles up from over 30 observatories worldwide, one thing becomes clear. 3I/Atlas is rewriting the rules of cosmic behavior. What could possibly drive dust toward the sun? The question hangs heavy, sparking whispers of propulsion. Yes, propulsion, in scientific circles. If this isn't just a natural comet, what is it? The answer, if there is one, lies in the data still pouring in. And as the world watches, the mystery only deepens. By early August, the James Webb Space Telescope, JWST, turns its powerful spectrograph on 3I/Atlas, pulling back the curtain on a chemical makeup that leaves even the most seasoned scientists stunned. The numbers are staggering. The object's coma, the hazy cloud surrounding its nucleus, is 8 times richer in carbon dioxide than water. For context, most comets in our solar system have a carbon dioxide to water ratio between 0.1 and 2, with the rare outlier creeping up to 4. 3I/Atlas sits 4 standard deviations above the norm, a statistical anomaly that screams alien. The JWST team, led by Martin Cordiner, confirms the measurement at 3.3 astronomical units from the sun, with the carbon dioxide signature dominating at 4.3 microns, dwarfing the waterline at 2.7 microns. Even carbon monoxide, a common player in distant comets, lags behind at a ratio of 1.4 to water. But the surprises don't stop there. The Very Large Telescope, VLT, in Chile picks up another bombshell, atomic nickel, pumping out at a rate of 10 to the 22.67 atoms per second. That's an enormous number for a comet still beyond Mars's orbit, outpacing even the brightest comets like Hayabusa at similar distances. Stranger still, there's no trace of iron vapor, which almost always accompanies nickel in solar system comets. The nickel and carbon dioxide production rates climb steeply as 3I/Atlas Atlas nears the Sun, with scaling exponents near -8 and -9, far sharper than the usual sublimation models. This isn't just chemistry, it's a chemical fingerprint from a world we've never seen, a time capsule from a distant star system where carbon dioxide froze out while water stayed locked deep within. These findings, published in peer-reviewed journals and corroborated by Hubble and JWST, paint a picture of an object that formed in conditions utterly foreign to our solar system. The sunward plume, rich in carbon dioxide and laced with nickel, matches the direction of the anomaly seen in earlier images. It's as if 3I/Atlas is shouting its origins to anyone who'll listen, daring us to decode its story. But the data raises a question that's impossible to ignore. Could this chemical cocktail be fueling something more than just a comet's natural outgassing? The idea of propulsion creeps closer, and the evidence is starting to stack up. If the plume and chemistry weren't enough to set hearts racing, the trajectory of 3I/Atlas is a statistical thunderbolt. Orbital dynamicists crunching numbers from observatories like Lowell and Gemini South find that the object's path is a cosmic outlier. Its orbital plane is tilted just 5 degrees from Earth's, a configuration with less than a 1 in 500 chance of occurring randomly. Most interstellar visitors slice through the solar system at steep angles, but 3I/Atlas glides in nearly parallel to our ecliptic, moving retrograde in a near straight line. Simulations show it will pass within 29 million kilometers of Mars on October 3rd, 2025, 97 million kilometers of Venus a month later, and 54 million kilometers of Jupiter by March 2026. The odds of hitting this planetary trifecta, less than 1 in 20,000. This isn't just rare, it's almost surgical. The object's eccentricity, clocking in at 6.141, sets a record for interstellar visitors, meaning its path barely curves as it whips through our system. For planetary defense teams, this is more than a curiosity, it's a wake-up call. An object threading the ecliptic, brushing past 3 planets in sequence, feels less like random debris and more like a calculated flyby. Monte Carlo simulations designed to test for observational bias only confirm the anomaly. This trajectory is a statistical unicorn. As July fades into August, the astrometric data reveals another twist. The object's predicted path, based on a gravity-only model, starts to drift. Residuals, the tiny differences between observed and calculated positions, grow to 0.7 arc seconds, more than double the expected scatter. The shift isn't random, it's consistently sunward, aligning with the mysterious plume. When analysts add a small, sun-directed acceleration term to their models, the fit snaps into place. The acceleration, measured at 4 × 10 to the -7th meters per second squared, is tiny but persistent, nudging 3I/Atlas thousands of kilometers off its expected course over weeks. For comparison, this is in the same ballpark as the non-gravitational push seen in 1I/Oumuamua, the first interstellar visitor, though that force pointed away from the sun. The data is relentless. The plume's direction, the chemical anomalies, and now a measurable acceleration all point to something extraordinary. To understand the weight of 3I/Atlas, we need to rewind to 2017, when the Pan-STARRS telescope in Hawaii spotted 1I/Oumuamua, the first confirmed interstellar visitor. That object was a puzzle from the start, small, cigar-shaped, and tumbling end over end every 7.3 hours. It didn't look like any comet or asteroid in our solar system. Its trajectory showed a faint acceleration, about 5 × 10 to the -6th meters per second squared, pushing it away from the sun, yet no tail or coma was visible. Even Spitzer's deep observations found no dust or gas, leaving astronomers grasping for explanations. Harvard's Avi Loeb proposed a radical idea. What if Oumuamua was a light sail, a thin artificial structure propelled by solar radiation? The mainstream pushed back, favoring natural causes like hydrogen ice sublimation, but the debate never fully settled. 2 years later, 2I/Borisov arrived, behaving like a textbook comet with a visible tail and familiar chemistry. It seemed to ground the conversation, proving interstellar objects could be conventional. But Oumuamua's ghost lingered, a reminder that the universe doesn't always play by our rules. Now, 3I/Atlas reignites that spark. Its sunward plume, carbon dioxide dominance, and non-gravitational acceleration echo Oumuamua's strangeness, but with a twist. This time, the anomalies are bolder, the data richer, and the implications harder to dismiss. The growing catalog of interstellar visitors, 3 in less than a decade, suggests we're only scratching the surface of what's out there. Let's dive into the heart of the mystery, that sunward plume. In a typical comet, solar radiation blasts dust and gas away from the sun, forming a tail that stretches millions of kilometers. But 3I/Atlas flips the script. Its plume, bright and persistent, jets straight toward the sun, resisting the solar wind's push. Hubble's high-resolution images, backed by Gemini South and Lowell, show a narrow, blobby arc that holds its shape across days, defying the diffuse spread of a normal comet tail. The dust is heavy, clumpier than expected, and moves with a velocity that suggests a directed force. This is where the propulsion hypothesis gains traction. Ion thrusters, used by spacecraft like NASA's Dawn mission, produce a narrow, collimated exhaust of charged particles, often xenon ions, that push steadily in one direction. The plume of 3I/Atlas bears an eerie resemblance. Focused, persistent, and pointed opposite the object's motion. If it were slowing down after an interstellar journey, firing a thruster toward the sun at perihelion would maximize the braking effect, a maneuver known as the Oberth effect. NASA's own mission planners use this trick to slingshot probes efficiently. Could 3I/Atlas be doing something similar? The chemical data adds fuel to the fire. While there's no xenon in the spectra, the carbon dioxide and nickel could, under the right conditions, be ionized and accelerated. The plume's heavy grains and high velocity don't match standard comet models, which predict broad, fan-like jets. Even the most energetic comet outbursts scatter dust widely, not in tight sunward streams. As one researcher puts it, if you wanted to hide a maneuver, perihelion is the perfect time. Earth's view is blocked by the sun, and that's exactly where 3I/Atlas is headed. On October 30th, 2025, 3I/Atlas slips behind the sun, entering a weeks-long solar conjunction that cloaks it from every telescope on Earth. This is the ultimate blind spot in planetary observation. No visible light, no radar, no way to see what's happening. For comets, perihelion is a moment of truth, where intense sunlight triggers peak outgassing, or in rare cases, disintegration. For 3I/Atlas, with its history of anomalies, this moment carries extra weight. Its plume, acceleration, and chemistry all point to something unusual, and now, at the peak of its kinetic energy, it vanishes from view. Planetary defense teams are on high alert. The Vera Rubin Observatory, nearing full operations, has flagged the conjunction as a critical watch period. Automated alerts ping across the network, and mission planners at NASA's Jet Propulsion Laboratory schedule follow-up scans for the moment 3I/Atlas emerges. If the object changes course, brightens, dims, or shifts its plume's behavior, the data gap could hide it. In the past, comets have split or faded during conjunction, only to surprise astronomers upon reappearance. For 3I/Atlas, the stakes feel higher. If its plume is more than dust, if its acceleration is more than outgassing, this is the window where a maneuver could slip by unnoticed. The world's best orbit fitters are poised, ready to pounce on the smallest deviation when 3I/Atlas reemerges. A tweak in trajectory, a change in the plume's brightness, or a shift in its chemical signature could tip the scales. Until then, the suspense builds and the question looms: what's happening behind the sun? The discovery of 3I/Atlas isn't just a single event, it's a harbinger of a new age in astronomy. The Vera Rubin Observatory, set to scan the southern sky every 3 nights, will soon transform our view of the cosmos. Its massive camera, capable of capturing billions of stars and galaxies, is expected to spot at least one interstellar visitor per year, possibly more. Simulations suggest millions of these objects pass through our solar system annually, most too faint or fast for current telescopes. With 3 confirmed visitors in less than a decade, the catalog is growing, and each one brings new questions. This flood of data will challenge astronomers to separate the ordinary from the extraordinary. Some objects will be icy comets like Borisov, others dark and silent like Oumuamua. But outliers like 3I/Atlas, with their strange chemistry and rule-breaking behavior, will demand closer scrutiny. Planetary defense teams are already rethinking their protocols, preparing for a future where fast-moving, unpredictable objects are the norm. The stakes are high. An interstellar visitor on a collision course could arrive with little warning, and 3I/Atlas's precise trajectory is a stark reminder of how close these objects can come. As the data pours in, the universe is revealing itself to be far stranger than we imagined. Each interstellar visitor is a messenger carrying clues from distant star systems. 3I/Atlas, with its sunward plume, carbon dioxide dominance, and subtle acceleration, is a puzzle that doesn't fit neatly into any box. Is it it a comet with an attitude, a fragment of alien geology, or something else entirely? The answer lies in the data still to come, and the world is watching. The saga of 3I/Atlas isn't just a story of numbers and telescopes. It's a deeply human journey of curiosity and discovery. Across the globe, scientists, amateurs, and stargazers are united by a shared sense of awe, poring over data, debating theories, and imagining what this object might mean. The anomaly of its sunward plume and its alien chemistry stirs something primal, the urge to explore the unknown. From the Atlas survey team in Chile to the analysts at NASA's Jet Propulsion Laboratory, thousands of minds are working to crack this cosmic code. But it's not just about equations or spectra, it's about what these findings say about our place in the universe. Are we alone, or is 3I/Atlas a hint that the galaxy is buzzing with activity we've only begun to glimpse? This question, as old as humanity itself, feels closer than ever as we stand on the cusp of a new era of discovery. Consider the bigger picture. The Milky Way is vast, a swirling disk of 100 billion stars, each potentially hosting its own castaways, comets, asteroids, and perhaps something more. The arrival of 3I/Atlas, following Oumuamua and Borisov, suggests our solar system is a cosmic crossroads, swept by debris from countless other stars. The Vera Rubin Observatory's projections are staggering. Millions of interstellar objects may pass through our system each year, most slipping by unseen. Each one is a snapshot of another world's history, forged in the fiery crucibles of distant suns or the cold voids between them. 3I/Atlas, with its nickel-laced coma and carbon dioxide plume, is a reminder that the galaxy's story is far richer and stranger than our textbooks suggest. As our technology advances, we're not just finding more objects, we're uncovering a tapestry of chemical and dynamical diversity that challenges our assumptions about how planetary systems form and evolve. What makes 3I/Atlas so gripping is how it teeters on the edge of possibility, blending the known with the unthinkable. The propulsion hypothesis, while speculative, isn't just science fiction, it's grounded in the data. The sunward plume, the non-gravitational acceleration, the precise trajectory. Each piece of evidence nudges us toward questions we're almost afraid to ask. Could this be a natural phenomenon we don't yet understand, like a supervolatile jet or a spinning nucleus with uncanny timing? Or could it be something engineered, a relic from a civilization that mastered interstellar travel? No agency has confirmed artificial origins, and the scientific consensus leans toward natural explanations, but the anomalies keep piling up. As 3I/Atlas approaches its solar conjunction, the tension is palpable. This object, born in the depths of another star system, is forcing us to confront the limits of our knowledge, and the tantalizing possibility that the universe has more in store than we ever dared to dream. Imagine a world far beyond our own, orbiting a star whose light will never reach Earth in our lifetime. A place where carbon dioxide ices dominate the frozen landscapes, and nickel-laced minerals glint under an alien sky. This is the cradle of 3I/Atlas, a fragment of a planetary system that may have formed billions of years ago, long before our sun ignited. Its journey to our solar system is a saga spanning light years, a testament to the chaotic beauty of the cosmos. Ejected from its home, perhaps by the gravitational tug of a passing star or the violent birth of a new planet, 3I/Atlas wandered the interstellar void, a silent traveler in the vast emptiness between stars. Its surface, scarred by cosmic rays and micrometeorites, holds the story of a universe we can barely comprehend, a story now unfolding in our telescopes. The carbon dioxide dominance and nickel signatures suggest a formation environment unlike anything in our solar system, perhaps a cold, volatile, rich region far from its parent star, where water was trapped deep within and carbon dioxide ruled the surface. This object isn't just a comet, it's a relic, a cosmic postcard from a place we may never visit. As astronomers pore over its spectra, they're not just analyzing dust, they're peering into the chemistry of a distant world, piecing together the conditions that shaped it. The sunward plume, with its heavy grains and persistent jet, adds another layer. Could this be the last gasp of ancient ices, or something more deliberate? The question isn't just scientific, it's existential. 3I/Atlas challenges us to wonder what else is out there, drifting in the dark, waiting to be found. The precision of 3I/Atlas's trajectory is a marvel that keeps astronomers up at night, their computers humming with simulations that try to unravel its path. This isn't just a random flyby, it's a choreographed dance through our solar system, with Mars, Venus, and Jupiter as its partners. On October 3rd, 2025, it will skim within 29 million kilometers of Mars, close enough to feel the planet's gravitational whisper. A month later, it will glide 97 million kilometers from Venus, its sunward plume glowing against the planet's reflective clouds. By March 2026, it will swing within 54 million kilometers of Jupiter, the gas giant's massive gravity tugging ever so slightly at its course. The odds of this triple encounter, less than 1 in 20,000, make it feel like the universe is playing a high-stakes game of cosmic billiards. Each flyby is a chance to study 3I/Atlas up close, but it's also a reminder of how little we control. Planetary defense teams trained to track near-Earth asteroids are now grappling with a new reality. Interstellar objects don't follow the same rules. Their paths are unpredictable, their origins unknown, and their behavior, like 3I/Atlas's sunward plume, can defy explanation. The Vera Rubin Observatory, with its relentless sky scans, is gearing up to catch more of these visitors, but 3I/Atlas is a wake-up call. Its trajectory, so eerily aligned with our ecliptic, suggests that the galaxy's debris field is more crowded and complex than we ever imagined. As it threads this planetary gauntlet, scientists are racing to model its every move, knowing that even a slight deviation could rewrite the story. The dance is beautiful, but it's also a test of our technology, our understanding, and our readiness for whatever the cosmos throws our way next. As 3I/Atlas barrels toward its solar conjunction on October 30th, 2025, there's a haunting stillness in the anticipation, a moment where science meets the sublime. The object's silence, its refusal to fit neatly into our models, speaks louder than any telescope image. For weeks, it will hide behind the sun's blinding glare, its secrets locked away in a cosmic vault. This isn't just a gap in data, it's a pause in our collective breath, a chance to reflect on what 3I/Atlas represents. Is it a natural oddity, a comet with a flair for the dramatic, sculpted by forces we don't yet understand? Or is it a whisper of something greater, a sign that the galaxy is alive with possibilities we've only begun to imagine? The propulsion hypothesis, while unproven, stirs the imagination like few discoveries can. The idea that 3I/Atlas might be more than a rock, that it could carry the fingerprints of an intelligence beyond our own, ignites a spark of wonder that transcends borders and generations. Scientists remain cautious, grounding their work in data, but even they can't ignore the allure of the unknown. The sunward plume, the precise trajectory, the alien chemistry, all of it feels like a message, encoded in light and motion waiting to be deciphered. As we wait for 3I/Atlas to emerge from its solar veil, the silence of the stars becomes a canvas for our hopes and fears. This object, born in the depths of another star system, is a reminder that the universe is vast, unpredictable, and full of mysteries that challenge our very sense of reality. Whatever it is, 3I/Atlas is a call to look up, to question, and to dream of what lies beyond. The discovery of 3I/Atlas feels like the opening line of a conversation with the cosmos, one that humanity is only just beginning to understand. Each data point, the sunward plume, the carbon dioxide dominance, the nickel signatures, the non-gravitational acceleration, is a word in a language we're still learning to speak. This object hurtling through our solar system is a bridge between our world and the infinite expanse beyond, a tangible link to the processes that shape stars and planets across the galaxy. The scientific community, from the graduate students crunching numbers in dimly lit offices to the veteran astronomers peering through the world's most powerful telescopes, is united in a shared mission to translate this cosmic message. But it's not just about the science, it's about the stories we tell ourselves about the universe. For centuries, we've gazed at the stars, weaving myths and theories to explain their mysteries. 3I/Atlas, with its defiant behavior and alien origins, invites us to write a new chapter, one that blends rigorous data with the audacity to imagine. The propulsion hypothesis, while speculative, isn't just about whether this object is artificial. It's about whether we're ready to accept that the universe might hold surprises beyond our current paradigms. As observatories like the Vera Rubin prepare to flood us with new discoveries, we're entering an era where interstellar visitors will become familiar, each one a chance to refine our understanding or upend it entirely. 3I/Atlas is a herald of this future, a reminder that every object we detect is a piece of a larger puzzle, a fragment of a galaxy that's been spinning stories for billions of years. The question isn't just what 3I/Atlas is, it's what it means for us as a species standing on the threshold of cosmic exploration to encounter something so profoundly strange. There's a weight to the wonder of 3I/Atlas, a gravity that pulls at the heart as much as the mind. This isn't just a scientific anomaly, it's a moment that crystallizes our place in the universe, a fleeting chance to grapple with the vastness of existence. Every telescope trained on this object, every simulation run, every heated debate in conference rooms and online forums is a testament to humanity's relentless drive to know more. The sunward plume, defying the solar wind, feels like a challenge issued by the cosmos. Figure me out. The chemical makeup, rich with carbon dioxide and nickel, whispers of worlds so alien they make our own seem small. The trajectory, threading past Mars, Venus, and Jupiter with improbable precision, feels like a cosmic dare, urging us to question whether chance alone could orchestrate such a path. As 3I/Atlas approaches its solar conjunction, the world holds its breath, not just for the data, but for what it represents. A chance to touch the unknown. This object born in the fires of another star carries with it the weight of billions of years of history, a story that began long before humanity's first spark of consciousness. Whether it's a comet, a relic, or something beyond our imagining, 3I/Atlas is a mirror reflecting our curiosity, our fears, and our hopes. It asks us to consider what it means to be a species reaching for the stars, to be explorers in a universe that's both beautiful and bewildering. As we await its reemergence from behind the sun, we're not just watching an object, we're witnessing a moment that could redefine how we see ourselves in the grand tapestry of the cosmos. This is where you come in. The mystery of 3I/Atlas isn't just for astronomers, it's for anyone who's ever looked up at the stars and wondered what's out there. The data is real, confirmed by NASA, Hubble, JWST, and dozens of observatories worldwide. The plume, the chemistry, the trajectory, all of it challenges what we thought we knew about the universe. As 3I/Atlas emerges from its solar conjunction in November 2025, new observations will either deepen the mystery or start to unravel it. What do you think it is? A natural comet with a wild streak or something more? Let's spark a conversation that reaches across the globe. If this story of cosmic intrigue has you hooked, give it a like to spread the word, and subscribe to stay updated as the next chapter unfolds. The facts are clear. On July 1st, 2025, 3I/Atlas was confirmed as an interstellar object moving at 130,000 miles per hour. Its sunward plume, 8:1 carbon dioxide to water ratio, and nickel-rich coma defy known comet models. A non-gravitational acceleration of 4 × 10 to the -7th meters per second squared aligns with the plume's direction, hinting at forces beyond simple outgassing. As it vanishes behind the sun on October 30th, 2025, the world waits for answers. This isn't just a story of science, it's a call to wonder, to question, and to explore. The cosmos is speaking. Are you listening?